Alrighty, so today I'm talking about components of a wave. And so first I'm going to draw a standard transverse wave. So it goes up and down and up and down and up and down, looking very similar to an oscillation. So it's going to have a lot of components to them. So first we recognize this as our amplitude. And that is how high it's swings. If this was like a midpoint or an equivalency point or a baseline, how high and low does it deviate from that? That's going to be the amplitude. Then we also can measure from here to here. So the amount of the distance a wave travels before it reaches the same point again in the wave is called the wavelength. And these vary a lot. But that's the wavelength. This would be distance. And then remember, if we're looking at this as far as time, we would think about period. And then two other things to know. We have these points right here in the wave, which when this wave is moving, if it were moving in a fashion of shaking, you would have these opposite patterns. But in these dots here, we have no motion. Where there is no motion, that is called a node. It looks like there's no motion at the nodes. It looks very stationary. And then you have antinodes. This is the most motion, or it travels the furthest. So your antinodes are here at the highest point and the lowest point of the amplitude. So where you have your max amplitude is where you're going to have your antinodes, and that's what's moving the most for the wave. So those are just some simple components